So we have two examples on this next page, one with a base larger than 1, and the second one with a base between 0 and 1. And so I'm going to go ahead and just kind of talk these through. Certainly you've got a calculator if you want to verify any of the things I'm writing down here or talking about. But we want to look at plugging in these various values of x into this function, 2 to the x. I'm going to go ahead and start first at 0. This was the important point we talked about. When you plug in 0 to any exponential function, 2 to the 0 would be a 1, right? I'll even write that. 2 to the 0 is going to give us a 1. So that means 0, 1 is a point. 0, 1 is a point on our graph. Okay, now I'm going to go ahead and do the positive ones first, since those make more sense to people usually. Plugging in a 1, you have 2 to the first. 2 to the first is just 2. Plugging in a 2 for x, 2 to the second is 4. And 2 cubed is 8. So we have the points 1, 2, right? Plugged in a 1, got out a 2. Plugged in a 2, got out a 4. Plugged in a 3, got out an 8. So we get those points, and we already see this behavior of it definitely increasing very, very quickly off to the right here. Now, as we go to the left, this is going to bring in our understanding of negative exponents. When we see, in this case, 2 to the negative 1, we need to remember that negative exponents essentially give us the reciprocal of that value. 2 to the negative 1 is the same as 1 over 2 to the first. You could put a 1 in there, a positive 1. We don't need to, because it's just 2. But 2 to the negative 1 is the same as 1 over 2, 1/2. So 1 over 2 to the first. So as best I can, kind of approximating the point negative 1, comma 1/2, about there. But now what happens when I throw a negative 2 in here? Well, the negative exponent part still requires me to take the reciprocal, but now that 2 is being squared, right? That's a negative 2 for an exponent. You move it to the denominator, now it's a positive exponent, so that's actually 1/4. Plug in negative 2, get out a 1/4. Okay, even closer to our x-axis there. And then we get to the negative 3, same thing, 1 over 2 cubed, so 1/8. As far as my drawing is concerned, I'm practically on the line at that point, but the idea, and you can see this pattern, as x keeps getting bigger, this fraction keeps getting smaller, 1/16, 1/32, and so on, but it's never going to get to 0. So this graph, as I'm doing my best to connect these points, is going to asymptote to our x-axis and go off very quickly to infinity as we go to the right. And so that would be our graph for the function y equals 2 to the x. And just in that small set of numbers there, you can see the pattern as to why this shape is the way it is. Again, two quick ones, the two important points. Plugging in a 0, always going to give you out a y value of 1. And plugging in a 1, always going to give you out the value of that particular base. 2 to the first, plugging in a 1, gave me 2. There's my point 1, comma, b, right? My base is 2. So then we look at the example with a base of something smaller than 1, something between 0 and 1. Still the case that if I want to plug in 0 for x, anything to the 0 there is going to give me a 1. So still the point 0, 1, right? All right, going through the positive exponents, 1/2 to the first will be 1/2. 1/2 to the second, squaring a 1/2 would give you 1/4. And 1/2 to the third, 1/2 times 1/2 times 1/2 would be 1/8. So you've got the points 1 and 1/2, 2 and a 4th, 3 and an 8th. So now you got 1 and 1/2, 2 and 1/4, 3 and 1/8. So we see this decreasing tendency in that asymptote behavior as we go off to the right. And if we look at these negatives, now what happens when I have 1/2 to the negative 1? We said the negative is supposed to give you the reciprocal of this value. The reciprocal of 1/2 is 2 over 1, or 2. So this is 2 to the first, or 2. So plug in negative 1, and we get out a 2. The next one, 1/2 to the negative 2. Again, for the negative exponent part, we take the reciprocal. Reciprocal of 1/2 is still 2, but now it's 2 squared. giving me 4. So I get the point -2, 4. And likewise for the last one, with a -3 for an exponent, gives me 2 cubed, gives me 8. So the point -3, 8. And now we see that pattern of the other parent function, that is the decreasing function that asymptotes as you go off to the positive infinity for x.